All right, guys, welcome back to the second part of 5.7, and we are going to be going over the second example, but it takes quite a bit of time, so let's just get right into it. Find all solutions for a triangle. If no solutions exist, write none. And again, I'm going to go back to our sheet here, and just follow this to figure out how many solutions we have in the first place. So our first thing is A is greater than or 90 degrees. So I'm going to stick to this right to this side. And from there we have is A less than or equal to B. No, it's not. So we have one solution. And so from there, let's just find the solution. First, I'm going to sketch a triangle. I know we're going to have to be greater than 90 degrees. And that's angle A at 112 degrees. And then across from A is 4. And if I said that's B and that's C, then B is 3 and that's just C. And from here, we have to do something that we might not have done before. So notice we have two angles missing in this one. And so we're going to have to use an angle to get some things. So let's involve our log signs. We have 4 over the sine of 112 degrees equals, and then let's pick another side. We know 3 all over the sine of B, and the sine of B is what we're going to want to solve for. So when we do that algebraically, we're going to multiply that sine of B over. So we're going to end up dividing by 4 and multiplying by the sine of 112. And then we have to take the arc sine, or the sine inverse of both sides, right, to get rid of that sine. And this is something that you just do in your calculator. And once you do that, you'll get that B is about 44.1 degrees. And if B is 44.1, then C is going to be 23.9. And that's just because 180 minus those two. And now we need to find, so we have the two missing angles, and now we need to find C. And so we know C all over sine of C, or sine of 23.9 degrees. And let's use the ones we have that aren't estimated. 4 all over the sine of 112 degrees. And again, we're just going to multiply that sine of 23.9 over, and all over sine of 112 degrees. And that will get us C equals about 1.75. And now our triangle is completely solved for. And there's only one solution, so we know that this is the solution. Now for our B, we have our angle A is 51 degrees. And so I'm looking here at our less than 90 degrees. And then we have A is less than or equal to B, or in this case, C, our other side. And so that leads us to this. So now we need to do what is C sine of A, and that's going to be C is 50 times the sine of 51 degrees, which is 38.86, about 38.86. And that is, we have A is 40, and 40 is greater than 38.86. So since we have that, we have two solutions. So we know we're going to have to find two separate solutions. And the trick here is we need to find what the sign of C is, because C is what's messed up. C is what we don't know what's going on. Because if we were to sketch maybe an angle that's 51, maybe is about like that. And let's do our acute one that we know we have. So if that's 51 degrees, and again, it's not going to be a perfect sketch enough. I said A, and let me draw a better triangle really quick. So if that's like 57, who knows how the rest is. I keep drawing it way up and over. If that's A of our 51 degrees, and A is going to be 40, and let's just do B and C, so then C over here would be 50. C is the one that is all janky and messed up, right? Because we're either going to be able to go out or we're going to be able to go in like this. But both signs of C have to be the same value. So let's find the sign of C. And how are we going to do that? Well, one of them. So let's do this one. Then we'll get using our law of sines, right? So now this is separate. Using our law of sines, we can do 50 over the sine of C equals, and then we can do 40 over the sine of 51 degrees. And then we can solve so that we get the sine of C on one side, and eventually we're going to get that the angle of C is 76.27 degrees about. And that's just from solving and putting your calculator. I trust we can do that, so I'm going to kind of skip that step. And once we have that, we can solve. That's our acute triangle, right? So let's just get that one out of the way. Horribly drawn, but doesn't really matter, right? A, B, C, as long as we can visualize it, we have C is 76.27, and that should be degrees. And we had A is 51 degrees. And when we solve it, that would leave B to be 52.73 degrees. And then again, we have A is 50, 50, and then 40. So now all we need to solve the last part of this is just this last side B. So this will be side B. And so we know that B all over the sine of 52.73 is equal to, and then again, let's use the ones that were given, 40 over the sine of 51. And then we multiply that sine of 52.73 degrees over. And when we do that, we're going to get that B is 40.94 degrees. Or not degrees, B is the sine length. So 40.94. And that's one solution to this, right? So you might be asking, well, how do we get the other solution? And, you know, our angle has to be the same, our reference angle, right? Because the sine of C has to be the same. So if I'm thinking here, 76 degrees is probably about that. on a graph. And then the reference angle, so the other way that the sine of C would be the same is if we had the same reference angle, so it would mirror that there. And we also kind of have to remember ASTC, where and like a triangle has to be less than 180 degrees. So we can't really work in those two quadrants, right? We have to keep it between 180 degrees. So we need this reference angle to be the same as that one. Well, that's going to be, so the real angle all the way around then is going to be 180 minus 76.27, which is going to be 103.73. So now we can make our new triangle, and we know it's going to be a little obtuse. And again, we have A, B, C, and now we're saying C is 103.73 degrees, and A is still 51 degrees, and we still have 40 across from B. No, other way. We have 40 for that length and 50 for this length. And now we're just doing the same thing again, right? We can do 180 minus those two to get our last angle. So angle B is 25.27 degrees. And then we're still looking for B. And so B all over the sine of 25.27 degrees equals, and then we can pick the 40 over the sine of 51 degrees. And when we solve that, multiply that sine over, we are going to get that B is about 21.996. And that is going to solve our triangle because we got the extra angle and the side that's missing, and we got this angle C. And so those are our two different solutions that we found, are those two different triangles. And I know I went a little fast for that, but really the important part is you guys should know how to solve these triangles with the law of sines at this point. The important part was really recognizing that it's two solutions, number one, and then finding the angle C, and then realizing that the other angle has to be less than 180 degrees and have the same reference angle so that the sine is the same, and that allows you to find what the other triangle is. So this is the real meat and bones of this one. And I know this one is kind of hard to wrap your head around, so I would definitely take notes and maybe watch this one over again, and definitely in class ask questions about this one, because this is kind of tough to wrap your head around, especially while going fast, and especially while virtually as well. But that is going to wrap up 5.7.